Alright, in the last section we looked at multiplying algebraic expressions. Now we're going to turn our attention to dividing them. And again, we're going to take it as three separate cases. So if we're dividing a monomial by a monomial, meaning there is no addition or subtraction happening anywhere, we basically already know how to do this. We're just going to apply our rules of exponents. In this example, in part A, we got 3x to the 8th over x cubed. You know, we're going to apply our rules of exponents. We know we can subtract those exponents. And we get 3x to the 5th. Next, it's basically the same situation, only I just have some more variables to take care of. It can be helpful to kind of tease out or separate out these the coefficients and the different variables from each other. I could write this if I want as minus 6 over 2 times s squared over s times t over t times z squared over z to the 4th. And then just deal with each of those separately. So negative 6 over 2 is negative 3. S squared over s is s to the 1st. T over t, well, that's just 1, right? Those cancel. And s squared, z squared over z to the 4th, well, that's, z to the negative 2 if I subtract those exponents. Usually we want to stick to writing only positive exponents in our answer, so we write this as negative 3s over z squared. Alright, in this next example, I got a similar situation here. Now 18 doesn't go directly into 8, or 8 doesn't go into 18 rather. So what I'm going to do is just sort of factor these. So 18 is 2 times 9, or 2 times 3 squared. I've got a cubed, b to the 6. On the bottom, negative, let's see, 8 is 2 times 4. I could have written that as 2 cubed, but I think that's going to, writing it that way is going to make it a little bit easier to simplify. And then a to the 5th, let's see, times b squared. So I'm going to write that a to the 5th as a cubed times a squared, and b squared Alright, so next we got a similar example. I'm going to, 8 doesn't go into 18, so I'm just going to kind of write these in what I think is a helpful way to facilitate some canceling. So 18 is 2 times 9, or 2 times 3 squared. Negative 8 on the bottom, that's a negative 2 times 4. I've got a cubed, a to the 5th, b to the 6th on top, b squared on the bottom. And I'm doing this just to kind of do some canceling here. So those 2's cancel. On top I'm left with a 9, and on the bottom I've got a negative 4. Alright, this next one is another kind of simpler example. There's no addition or subtraction happening. So what I'm going to do is just sort of rewrite the top and the bottom in what I think are helpful ways that will facilitate some canceling of factors. 18, I'm going to write that as 2 times 9. 8, I'm going to write that as 2 times 4. Of course it's negative, so I'm going to remember to bring that over. Now, if you look at those a's, I've got a cubed times a to the 5th. I'm going to write a cubed on top as a cubed. On the bottom, I've got more than 3 factors of a, so I'm going to write that as a cubed times a squared, just for convenience. And then on the bottom, I've got a b squared, so on top, that b to the 6th, I'm going to write as b squared times b to the 4th. Now there's more than one correct way to go about this. I did this just to kind of make it more convenient for myself to do some canceling. So the 2 cancels with the 2, the a cubed cancels with the a cubed, the b squared cancels with the b squared. I'm going to see what I'm left over with. Now overall I've got a positive over a negative, so this fraction is going to be negative. I'm going to take care of that first. Up top I've got 9b to the 4th. On the bottom I've got 4a squared. And that's as far as we can go. Our next scenario is, what if we have some addition or subtraction up top but not on the bottom? So again, we have a single term in the denominator, and when that's the case, we're just going to use, we already know how to add fractions that have a common denominator. We did this a while back. So if I have a common denominator, I just bring that denominator over, right, and I do the addition or subtraction with the numerators. But look, this fact works in two directions. And when we're using this fact to do some division, what I'm going to do is split up the fraction over any addition or subtraction that happens up top. So in this first example here, I've got 4a squared plus 8a all over 2a. So I'm just going to split up the fraction, 4a squared over 2a plus 8a over 2a. And then each of these fractions, I'm just going to simplify like I did the examples on the last page. Right now I've kind of split it up into two smaller problems. So 4a squared over 2a, we do a little reducing and canceling, we get 2a. 8a over 2a, the a's cancel, 2 goes into 8 4 times, so 2a plus 4 is what we get here. And this fact works no matter how many terms we have in the numerator. So here I've got 3 terms in the numerator. I still just have the one term on the bottom. So I'm going to split this up. I'm going to write this as 4x cubed y over 2x squared y minus, that's a minus because that's a minus, 8x cubed y squared over 2x squared y. And then plus, that's a plus because that's a plus, 2x squared y over 2x squared y. And then I can just simplify each of these fractions on its own. The first one, 2 goes into 4 twice, x squared, let's see, x cubed over x squared is x to the first, and the y's cancel. So we got 2x for the first term, minus 2 goes into 8 4 times, x cubed over x squared is x to the first, y squared over y is y to the first. And then in the last one, everything cancels, so we just have plus 1. Alright, so, in order to deal with the next scenario, we're just going to define what a polynomial is and its degree, and because that's important here. So, a polynomial is an expression where we've got usually just one variable. Here we're writing it as x. And then to different powers. I could have a constant term with no x's. There's a term with x to the first, then x squared, and then it has some maybe highest power. It goes up to a certain power of x. And they all have different coefficients. What makes it a polynomial is that the exponents are all positive integers, so no fraction exponents, no negative exponents. The highest power to which x appears is called the degree of that polynomial. So in example 246, we're just going to look at some expressions, determine whether or not these are polynomials. So the first one, this is a polynomial. Yes, it's a polynomial. It's degree 3. The second example, yes, that's a polynomial. Degree 7. Right, we just have positive integer powers on x. In part C here, this is not a polynomial because we can't have a square root of x. That's x to the 1/2, and we can't have fraction powers. And 1 over 4x to the fifth, it might at first look like we've got just positive powers on x, but that's really, an x to the fifth on the bottom is really a negative exponent. This is 1/4 x to the negative 5. So this is no, because negative exponents are not allowed. And now what we're going to do is learn how we divide polynomials. And this is what's going to allow us to examine what if I have addition or subtraction in the bottom, not just the top. Dividing polynomials, we're going to use an algorithm that's really similar to just long division with numbers. Now maybe it's been a while since you've had to do long division with numbers, so I'm going to just start this part by doing an example where we need to do some long division with numbers. So let's say I want to take the number 533 and divide it by 4. So the first thing I do is I look at the number 4 and I just say, okay, well, how many times does 4 go into 5? And that goes in once. 1 times 4 is 4, right? I take this one, I multiply it by the divisor, put it down there. We do some division, some subtraction. 5 minus 4 is 1, and then I bring down this next digit, and then I start the process over. I say, well, how many times does 4 go into 13? 4 goes into 13 3 times. 3 times 4 is 12. I do some subtraction, bring down the next digit, and I do it again. 4 goes into 13 3 times. 3 times 4 is 12. I do some subtraction, I get 1. Now I've got no more digits left over. And it's possible, you know, you might recall it's possible to get a decimal answer if we do like a 0.0 and bring down a 0, but that's not what we're going for here. We're going to get an answer using only fractions. And so when you have a remainder, that's what you put over your divisor to express this as a final answer. So the way we interpret this is that 533 divided by 4 is equal to, you take your quotient 133 and then say, and 1/4 is what's left over. So there's your remainder of 1. 1 out of 4 is what's left over. And this is really similar to the process we're going to use when we divide polynomials. So let's say I'm going to divide these two polynomials, 6x squared plus x minus 2, and I'm going to divide that by 2x minus 1. So 6x squared plus x minus 2. I'm dividing that by 2x minus 1. And the first thing I do is I'm going to look at just the first term of my divisor, just the first term inside, and ask myself, what do I multiply by 2x to get 6x squared? And that is 3x. Next, I'm going to multiply this 3x by my whole divisor, 2x minus 1, and then put that below here. So 3x times 2x minus 1 is 6x squared minus 3x. And I'm going to subtract just like we do with numbers. Only have to make sure here, parentheses are absolutely crucial. I have to subtract the whole thing. So 6x squared minus 6x squared, that's 0. That is by design, right? We picked out 3x because that is exactly what would make us subtract 6x squared from itself. So that leaves nothing. And then what we have is x minus a negative 3x. So that's x plus 3x, or 4x. And then we bring down our next term, minus 2. Next, we just start the process over again, and we say, okay, well, what do we multiply by 2x to get 4x? The answer is 2, and it's a positive 2, so the next term up here is plus 2. Next, I'm going to take this 2 and multiply. So that's 4x minus 2, and I'm going to subtract. Now in this case, 4x minus 2 subtract 4x minus 2 gives me 0. That means that 3x minus 2 goes in evenly with no remainder. So this result is simply this quotient 3x plus 2. And that's where we stop. Let's do another one. I'm going to take 4x cubed plus 6x squared plus 1 and divide that by 2x minus 1. So 4x cubed plus 6x squared plus 1. So I'm going to write that inside the division box. Now notice there's no x term here, right? I've got no x to the first term, which is fine. But when I write it in here to organize my work, I'm going to include an x term by just writing plus 0x. It's like a placeholder. I'm not changing what the expression's equal to because there are no x's. There's no x term. But that's going to make it easier for me to keep track of my work, to organize my work. And I'm subtracting this, or sorry, I'm dividing this by 2x minus 1. So I start the way we started the last time. I'm going to ask myself, what do I multiply by 2x to get 4x cubed? And that is 2x squared. Now I'm going to take that 2x squared and multiply it by the divisor here, 2x minus 1, and that gives me 4x cubed minus 2x squared. Now I'm going to subtract the whole thing. Parentheses are crucial here. 4x cubed minus 4x cubed is 0. 6x squared minus a negative 6x squared minus a negative 2x squared is 8x squared, positive 8x squared. Remember, if we're subtracting that negative, we're adding a positive 2x squared. Then I'm going to bring down the rest of my terms. I usually bring them all down, carry them all down with me as I go. Next, I just start the process over again. Now, what do I multiply by 2x to get 8x squared? That is 4x, a positive 4x, so this is plus 4x. Multiply 4x by 2x minus 1, so I get 8x squared minus 4x. So here, right here, this is why I include that 0x placeholder, because it lines up my like terms, and I'm less likely to make a mistake. I still have to be careful with my signs. I am subtracting the whole thing, so those parentheses are important. 8x squared minus 8x squared will cancel, as we expect. 0x minus a negative 4x is a positive 4x. Bring down the plus 1. Now, I think one more go here. 2x. What do I multiply by 2x to get 4x? That's 2, a positive 2, so up here is plus 2. And then I multiply 2 by my divisor, and I get 4x minus 2. Now I'm going to subtract the whole thing. When you do the subtraction, you get a positive 3. And here's when I know I'm done. When you subtract, and the degree of what you're left with after you're done subtracting is less than the degree of your divisor here, that's when you know you're done. So this is degree 0, 3 is degree 0 because there's no x's, and our divisor 2x minus 1 is degree 1. So I know I'm done, my remainder is 3, and the way I put this all together is I say that this fraction, this quotient is equal to, let's see what I got when I divided this stuff on top, 2x squared plus 4x plus 2, and then plus, you put your remainder over your divisor, 3 over 2x minus 1. And that is as far as we can go.